let's now invite our next guest, next speaker, who's Ruben, who's a senior machine learning specialist at Krisp. Hello everyone, I'm Ruben from Krisp. I'm a senior machine learning engineer. And today we're going to talk about visual emotion recognition. We'll cover what is emotion recognition, the classification of emotions, what approaches are there for especially visual emotion recognition. We'll talk about multimodal emotion recognition, taking into account multiple channels, about Krisp's approach on emotion recognition, on how to manage computational resources when you have multiple products, and the main topic, visual emotion recognition based on 3D based networks. And I'll share our results. So what is emotion recognition? It's the process of identifying human emotion, which can be done through many modalities. First, from facial expressions, like when you're happy, when people are happy, they usually smile. From speech signal, how they express their emotions while speaking. From text, actually the NLP task analog of emotion recognition is called sentiment analysis. It's not about only the emotions, but about the arousal level, how excited the speaker is, and about the balance, how positive the speech is. Another means of expressing emotions is the body language. You may see that I'm somewhat nervous from my body language now. And the electronic sensors and information. That is the physiological changes that happen to humans when they express emotions. And they can be captured via electrocardiograms, the thing they do to monitor your, the beating of your heart, and for example also the electronic signals from your brain. So what is visual emotion recognition? It is the process of analyzing human spatial expressions in order to get what emotion he is expressing, and that can be done both from static images and from visual signals. So let's talk about the classification of emotions, because in order to do emotion recognition, which is a classification task, you should specify classes. So Paul Ekman, a researcher who is actually a psychologist, conducted research in 1970 that showed that there are 7 main emotions, which are anger, happiness, disgust, sadness, fear, surprise, and the absence of any emotion, which we call the neutral emotion, that are universally and cross-culturally connected with particular facial expressions, which means that people from various cultures, genders, and ages express their happiness more or less the same way. They smile. So what approaches are there for emotion recognition from visual channels. Historically, for the classification task, SPM support vector machines performed very good, and then the same person, Paul Ekman, came up with a system which is called facial action coding system that represents, introduces action units, which are the means by which people express emotions, facial expressions that are connected to emotions, like are the eyes closed or are the eyebrows raised or not, and based on that, the approach is based on the action units. There are sets of action units that have correspondence to certain emotions. Like when you're happy, you usually smile, so the corners of your lips are raised, your eyebrows maybe are somewhat raised, and so on. When it comes to detecting emotions from single images, the current state of the art and the historic solutions usually are based on convolutional neural networks. But when it comes to doing emotion recognition from video, RNNs, recurrent neural networks, particularly LSTMs and gated recurrent units, are more popular because they can capture the context also. And the state of the art in emotion recognition from multiple channels, which is called multimodal emotion recognition, uses actually attention-based LSTMs. You can see presented the state of the art in research for visual emotion recognition. This is actually a screenshot from the website Papers with Code, and those are the benchmarks on AlphaConnect data set. So more or less the accuracy for the aforementioned 7 emotions is around 65%, and most of them use convolutional neural networks like ResNets, EfficientNet, so on. So what are the main steps to do visual emotion recognition? To detect emotion from facial expressions, you first have to find face. You can actually have networks that take images input and try to elaborate that way, but it's easier for the computer, for the machine, when the researcher can distinguish between the problems that can be separated. So the first step is usually face detection, and on that detected face, or by that we mean actually a cut rectangle on an image where only human face is present, and from the effort usually future extraction is done. That may include those action units defined by Paul Ekman that I covered, or maybe some landmarks. And based on that, the main part, the classification is done. So with Krisp, have a mission to empower professionals to be effective communicators. And for that, we are making many wonderful technologies. one of which is emotion recognition. And based on the research that we conducted, we've seen that multimodal emotion recognition is what that computers can do most in terms of emotion recognition. So we do emotion recognition from multiple channels, from speech, audio, from video, and from text. Not currently, but all of them are in the plans. Currently, we are working on having separate models for each channel and combining them decision level. I'll talk about the visual emotion recognition part. So, talking about the technologies that we make, we have currently outbound noise cancellation, inbound noise cancellation, echo cancellation, and virtual backgrounds that are currently in beta. And all of these have a decent CPU consumption. So that is the trade-off that we have when we are expanding the list of our technologies, of our models. We do have some constraints. So the models that we are making should be lightweight, have low CPU usage, and most of the time they should work real time, because we want to help people communicate better at that moment. So I'm going to talk about doing visual emotion recognition from facial landmarks. I'm asking now the audience what emotion they think the person is expressing based on those landmarks. Don't you think he's happy? Yeah. Yes, it was me, and I was happy actually. So that was what we were, what we hypothesized, that there are actually some approaches, but what we wanted to know if is it possible to have a simple deep neural network, not many, not like state-of-the-art networks, but just a simple DNN, and fit the 3D facial landmarks to that network, and have an emotion classification based on that. So what we used for the research purposes, the Google's media pipe, you can check it out via the QR code actually. For most of the computer vision tasks, they already have a good solution. And if you do anything computer vision related, you should check them out, as they mainly define the state of the art in some cases. So they have two solutions which are relevant to our today's topic. First is face detection. You can see that red bounding box, and face mesh, which gives 468 3D face landmarks real time, even on mobile devices, which means the model is lightweight and fast, meeting our requirements. And this face mesh actually does face detection in itself also. So the diagram for our approach: in the training stage, we have Actually, I want to talk about the data sets also. It isn't very easy. I'd say it's hard to find decent data sets, and even when you find them, there is a problem, class imbalance problem, which can be fixed by introducing weighted losses. But I mean, the data is really a problem in emotion recognition, also, because it is somewhat subjective. So in the training stage, we have a data set of annotated images. We run the MediaPipes face mesh technology on them to get those 468 points. Do some normalization techniques on them, and the neural network visualized by this simple architecture is done. And when it comes to inference, on an unseen image, we compute those 3D landmarks also. Some sort of normalization is also done there. And so the NN predicts and gives an emotion label. What is interesting are the results, which are comparable to the state-of-the-art we covered. With this approach, the multi-class accuracy for 7 main classes on a completely unseen data set is 65% around. And actually the multi-class accuracy for the class emotion classes that occur in real life more, which are the angry, happy, sad, and neutral. You don't see the disgust, for example, that much on a daily basis. The multi-class accuracy for those relatively easy to detect emotions is around 85%. Here you can see some examples of images that our network did manage to predict the emotion for. That's it, maybe. I'll be happy to answer if there are any questions.
Thank you. So let's take the first question. Thank you for an awesome speech. So I guess that the lack of quality data is even more pronounced for classification of children emotions, and children kind of have different facial expressions. So what about reading children's emotions? Is there any research on that? Maybe transfer learning or something like that?
Thanks for the question. Actually, the research conducted by Paul Ekman that I talked about did include children also. But I see the point that children do express emotions differently. But at Krisp we didn't cover that yet because our target audience doesn't include children.
Yeah, thank you very much. Could you kindly comment on your thoughts in terms of training across multiple modalities? For example, tone informing inference on the facial expressions, vice versa?
Thanks for the question. In terms of multimodal emotion recognition, there are two main approaches. One is decision level fusion, which I did cover and what we are currently thinking of doing at Krisp, which is when you have different models or different channels of information, and you just combine their decisions with some weights to get the final answer. And there is also future level. When you combine the different modalities, future level, and there is some research that shows that there are some interconnectivities between modalities, and actually you can get the real emotion only when you cover both audio, video, and text, because maybe when someone smiles and says a sarcastic thing when smiling, the sentiment is actually negative, but you couldn't get that solely from image information. So there is some research. I can share it to you, with you afterwards, that says that there are some interconnections between different modalities, and that's it. To get final answer, you should cover every one of them.
Thank you for the interesting talk. For RNNs and other time series-based models, how do you account for dropped frames and lag in video?
I didn't get the question. Count of dropped frames or what?
How do you account for dropped frames and lag in a video?
Actually, I got it. Thanks for the question. Actually, when doing emotion recognition from video, it is very computationally expensive to run the emotion recognition on every frame. So the state of the art that we've seen that wants to work real time, they actually intentionally do skip frames and do achieve competent results. So that may be just your concern may be covered by that kinds of networks that don't do detection or recognition on every frame, but do intentionally skip frames and do run under recognition on frames that are significantly different from each other. That I believe that should account the problem of skip frames.
Thank you for the talk. I'm wondering, does your solution work on the faces from angle view, and does the emotions recognition happen when the person not looking forward with the angle view? And how do if no, how do plan to solve it?
Thanks for the question. The technology we used for this is actually a research proposed project that I'm presenting, uses the facial landmarks from Google's media pipe, which did account different angles, and when people are not looking directly but looking sideways, it works not the same, but it does give good landmarks for that case also. I mean, that is not in the scope of the architecture and training that I presented, but it's in the scope of extracting the facial 3D landmarks, and those are 3D, so when you are looking sideways, you have information about the points that are not seen in the video as well. And so Google did a very good job on that. And the model does actually work when not only looking directly on the camera.
Other questions?
Thanks for the talk. Yeah, I have basically 3 questions. What's the business idea behind it? How you are going to use it? The second one, how are you going to solve the problem of the imbalanced classes? Like, is it fine for the time being to have this Gast and the other ones having low accuracy? And the third one is more research one. Have you tried also the transformers instead of RNNs or etc.? So transformer side of the problem. Thank you.
Thanks for the questions. I'll address them one by one. About how the business will use it. So, as we want people to become better communicators in the online platform, we want to tell them information about like how fast they are speaking. Will the listeners get him? Is he using like some filler words to lower the percentage of use of those filler words? And also we are why are we shipping these emotion recognition features? For example, when you are going to do a presentation or a talk that has to have positive context, you are supposed to express happy expression, or at least not to express like disgust or sad or angry emotion during that talk. And also somehow this emotion recognition and the sentiment analysis and arousal analysis is connected to the confidence level that the speaker has. Another interrelated topic is the estimation of arousal and valence besides the emotions, where arousal is basically how excited you are when talking, or how good your speech is. And that information can be very helpful when presented to the speaker to communicate more effectively. That's for the first question. About the class imbalance, what we used, we did introduce weighted loss in the training process to have weights corresponding to the sizes of the classes that we have in the training process. That not 100%, but it does to some extent solve the problem of imbalanced data. And regarding the transformers, we have not yet tried them at Krisp for visual emotion recognition, but we do use them for many other projects and tasks.
Thank you. Okay, let's take the last question as well.
Thanks for the speech. So, as we know, some people are more emotional than others, and maybe we can even divide this by regions, like Italians are more emotional than British and things like that. So, I'm wondering, do you have any kind of maybe model adaptation for this, for particular speaker or something like that? Or you are using the same model for all?
Thanks for the question. There are two sides in my answer. Actually, there is such kind of problem that we did meet, that based on the culture, based on the country, based on belonging, people do express emotions differently, but that is mainly seen in speech. I mean, like Italians and maybe Germans are more expressive in general. So one of the approaches to have a more generic algorithm that will the data set may be more generous and include multiple cultures, countries, and genders and ages, but that would work not that well. And another approach is to have specific models for each continent, country, or culture. Krisp currently is targeting the business professionals that are mainly using English as the language of their communication. And a big part of our audience is from US. So the current versions that were, the first versions that we're going to ship are going to work best for an average American.
Thank you. So let's thank Ruben one more time.
You may connect with me via LinkedIn and we can talk about emotions more.